Hello everyone, this is Nandish Trivedi from ICD 18 batch of Pandit Deen Dayal Petroleum University. The following video that you will see is a brief presentation about page replacement algorithm simulation in an Android application. The following project has been made by me and my two colleagues Mehul Sudrik and Kalariya. Let us now move to the implementation of this application in an Android phone. The first you will see a login page with our names and our batch and the year. The following is an home page. The home page basically shows the 5 algorithms and one function. The 5 algorithms that have been implemented under the following app are FIFO page replacement algorithm, LIFO page replacement algorithm, LRU page replacement algorithm, optimal page replacement algorithm, and random page replacement algorithm. The function is an auto select page replacement algorithm. The auto select function will give you the best output according to your input. Now what does that mean? This means that for your input it will give you the algorithm which will have the lowest page fault. Let us move to one by one implementing these algorithms. We will first go with FIFO page replacement algorithm. As the name suggests, this algorithm works on the principle of first in first out. It replaces the old age page that has been present in the main memory for the longest time. It is implemented by keeping track of all the pages in a queue. Let us now move to the input page. As you can see, the input page has two text boxes. The first, you have to enter your frame size. The other, you have to enter pages. Let us keep the frame size as 1. As here we will be seeing Belady's anomaly. I will explain about that in later part of the FIFO algorithm. Now let us enter our input. Our input will be 0. Then you have to press enter. 1, enter. The process has to be followed for every page you are entering. Now let us hit on the calculate button. From here you are transferred or you are navigated to the FIFO algorithm page. Here as you can see there will be 12 sets. Now what does that mean? This means that the entire FIFO algorithm will be running has been run 12 times and 12 steps are required to have the output of the following input. Here when a page is present in the frame size, it will give a hit which is represented by green. When it is not present in the frame, it will give a fault which is represented by red. Currently when the 0 page entered the frame, it was not there and hence it showed a fault. In this application you will also be able to see what is the hit and the fault ratio at every step of the process. Let us move to the next set. Here 1 again was not present in the frame and hence it was a fault. Again 5 was not present, a fault. 3 was not present, a fault. 0 was not present, a fault. 1 was not present, a fault. 4 was not present, a fault. 0, it was present, hence it's a fault. It's a hit. 1, again it is present, it is a hit. 5, again it was not present and hence it's a fault. Now as you see, 0 was the least used element and was the last element that had was the first element that had entered and hence it has been removed. Again similarly 1 entered after 0 and hence it has been removed and replaced by 3. Now 4 was present and hence it is a hit. Now let us go to the concept of Belady's anomaly. What is Belady's anomaly? Belady's anomaly is the name given to the phenomena where increasing number of page frames results in an increase of page faults for a given memory access pattern. This phenomenon is generally or commonly experienced in the FIFO algorithm. Here, the Belady's anomaly has been visualized using lines and bar graphs. Now here as you will see, as the line chart animates, that as we increase the frame size from 3 to 4, please look at the pointer, the page fault has increased. However, this is only observed, interestingly, when the page size increases from 3 to 4 and not for other cases. It's an interesting observation which is true for many cases, which may be wrong for many cases. Let us see a bar graph visualization for the same. Now as you see, for the 2 frame size we have the maximum number of page faults, which is a very evident thing. It decreases when we go to frame size 3. However, it increases when we move to frame size 4, and hence this is the Belady's anomaly. Let us compare this FIFO algorithm with others. The comparison has been visualized using a bar graph again with other algorithms like optimal, LIFO, LRU and random. Here as you see, LRU gives us the first performance in terms of faults, and optimal gives us the best. As the name suggests, it must be an optimal solution. Let us move on and see the implementation of LIFO algorithm. LIFO, as the name suggests, this algorithm works on the principle of last in first out. It replaces the newest page that arrived at last in the main memory. It is implemented by keeping track of all the pages in a stack. Let us move to the input page. Here from now on, for the next 4 algorithms, we will have a standard input that we'll be using. Let us go with that input. The frame size for that input is 4. The standard input will be 7 followed by a 0 followed by a 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2. Not to misunderstand this, a standard input has been taken because it will help in studying the comparison, Belady's anomaly and every other aspect of the page replacement concept, and hence we will be going with a standard input. However, you can choose any input you want and you will get the solution according to the algorithm you have selected. Let us hit on the calculate button. As you see, now you are navigated to the LIFO algorithm aspect. Here again, 7 was not present, hence it was a fault. 0 was not present, a fault. 1 was not present, a fault. 2 not present, a fault. 0, it was present, hence it's a hit. Similarly for 3, it was not present, and 4, fault. As you see, the last page that had entered or the newest page was 2 and it was replaced. This is the LIFO algorithm. Again, 0 was present, hence it's a hit. As 4 was not present, 3 was replaced. As 2 was not present, 4 was replaced. Again, 3 was not present, hence 2 was replaced. 0 is already present, hence it's a hit. 3 is already present, it's a hit. 2 was not present and 3 was the last page coming in, and hence it has been replaced. The process has now been complete. Now we will check whether LIFO suffers from a Belady's anomaly or not. Now as you see, the Belady's anomaly does not hold true for this LIFO example, and generally it should be the case as it is most observed in the FIFO algorithm and not in anyone else. Let us see the bar graph visualization. Alright, it's the same like the line graph. Let us move to comparison with other algorithms. When we compare the following input with other algorithms, we can see that LRU and optimal are supposed to give us the best solution. We will see that they will give us 6 page faults when we implement them. Let us move back and now implement an LRU algorithm. What is LRU? LRU refers to least recently used algorithm. It replaces the page that has not been referred by the CPU for the longest time. I will explain what does that mean. Let us go with our standard input. Let us hit on the calculate button. Now you will see what does the statement that the page that has not been referred by the CPU in the longest time will be swapped. Here again 7, 0, 1, 2 were not present, hence there were 4 false. Now 0 was present. Now 3. Alright. 3 is the next element that will be coming according to our input. Now as you see, the page that has been referred last by the CPU was 7, and hence we must expect that 7 should be swapped by 3. Yes, it was the case. As you see, 7 was the first element that had entered and it had not been referred by the CPU since then, and hence according to this algorithm it was swapped. Now again 0 was present. Now 4 was not present. As you remember, 0 was referred last. Before that, 1 was the second element, 1 was the least referred page by the CPU, and hence it was replaced by 4. The process will continue. Now we have a page fault of 6. Let us see. As we saw in the LIFO comparison that it must be 6, and we got the 6. Let us see whether Belady's anomaly holds for an LRU algorithm. As expected, the LRU algorithms does not hold true for Belady's anomaly. This is because it generally is for stack-based algorithms like FIFO that these type of Belady's anomaly occur. However, they in FIFO also do not occur every time. These are a special case of inputs which may cause these Belady's anomaly. We will see the bar graph for this. As you can see, the bar graph also shows that by increasing the page frame size, the number of faults is decreasing. Alright, let's compare it with others. Now in this case, you may observe that random last time gave us worst performance. About this we will talk when we choose the random page replacement algorithm. However, as we can see, LRU and optimal give us the best solution. Let's move on to optimal page replacement algorithm. Now, optimal page replacement algorithm, as the name suggests, should give us the most optimal solution, and that is true. Optimal will give us the best solution every time, no matter what is the input. However, this is not practically possible to implement. Why? Because in optimal page replacement algorithm, the algorithm will look into the future. This may be true for a given set of inputs like new integers that we are giving. However, this may not be true in a practical operating system where we don't know what we need to access next, and hence we can't look into the future. Let us go through the algorithm. Again, we will give a standard input. Alright, 7012. Now as you see, for replacing the algorithm will see into the future that which page is not referred in the future, and hence it will replace this. Just like LRU, in this 7 will not be referred according to our input in near future or in the entire input, and hence it must be replaced right now. Yes, it is replaced. This is because 7 is not present in the future pages that the algorithm wants to access. Alright, let's move on. 30. The 0 was already present, hence it was a hit. Now 4 was not present. Now 1 is also will not be referred in the future, and hence it has been swapped. Let's move from 4. We have 2, that is a hit. We have a 3, that is a hit. We have a 0, that is a hit. We have again a 3, that is a hit. A 2, that is a hit. Here as we see, page fault is 6, page hit is 7. It is similar to LRU. Thus, for our standard inputs, the LRU and optimal are giving us the same solution. Let's see whether Belady's anomaly will hold true. As we see, Belady's anomaly does not hold true for optimal algorithm, and it was expected, right? Let's see a bar graph visualization for this. Let us now compare it with others. As you can see, LRU and optimal are giving the best. Random again did some stuff which we will go through in the next part, and as we saw, LIFO and FIFO give us 9 and 7 respectively. Let's move on and do the random algorithm. Now what does random algorithm mean? This means that the algorithm will replace any page randomly from the frame, and hence it may behave like FIFO, it may behave like LIFO, hence it may also behave like LRU and optimal, and hence we cannot say what will be the performance. Every time the algorithm runs, the performance will be different. which is not the case for other algorithms. There is a structure, there is a proper structure in which the output will come. However, for random algorithm, there is no structure, there is no definite output, and hence the performance will be different every time. We will see such examples in our application as well, because from when you move from input pages to Belady's anomaly checking, or even for compare with others option, you will see that the random will give different faults. Let us go and quickly enter the input so we can see this variation. Let us hit on the calculate button. As you see, randomly pages are being swapped in, swapped out. As you see, here we have seen that it is behaving exactly like LRU and optimal. Page hit is 7, page fault is 6. However, let me show you how this variation will change when I go for Belady's anomaly. Remember, the page fault was 6. Let us go for the Belady's anomaly and see for 4 what does it give right now. As you see, currently it gave us the same output. Let us go for the bar graph. Again, it was the same. Now let us compare it with others. As you see, when I compared it with others, the random was first 6. When was first, the page fault was 6. However, in this case it has gone up to 7, as you can see here. Alright, so this is the random behavior that I was talking about. You don't get a definite output every time. Output will be every time different. Let us go to a special auto select PRA, that is the auto select page replacement algorithm. Now what does this function will automatically choose a page replacement algorithm which gives best output for a given set of inputs. Now what does that mean? As we saw in the first case that there was a Belady's anomaly, the input was different. For all the other algorithms, we choose a standard input for which LRU and optimal gave us the best solution. In this algorithm, whatever input you give, the algorithm with the minimum page fault, that means the minimum page fault value will be selected for you automatically. You need not do anything, just give your input and the algorithm will just come up. Now in this case, the optimal is not considered. This is because optimal is always giving us an optimal solution, and hence it does not make any sense to compare it with or to keep it in an auto select because every time we will get optimal, and hence the comparison is only between FIFO, LIFO, LRU and random algorithm. Let us go for the input and for our standard input, and as we know, we should get LRU as our best algorithm. Let us go 4. Alright, let's calculate. As you saw, we got the LRU algorithm, as you can see here. Alright, now let us go ahead, and for people who will directly use this function, we also have given an option so that you can compare it with others and know that LRU will always give you the best output in this input. As I said, optimal is not considered as it will always give us the best solution, and it does not make sense to compare to keep it in an auto select condition. Yes, and as we see, LRU is giving us the 6th option. So here I come to an end of this presentation video. I hope you all enjoyed and will use our app. If you want to further develop or add any functionalities, add different algorithms to the following application, the entire source code is available on our GitHub profile. We will put the URL of that GitHub profile in the description below. Thank you very much.